Alright, you guys, we are back. We are going to be talking about real world graphs. So go ahead and open your packet to this page right here, describing real world graphs. So here the graph shows the height of a roller coaster during a single ride. Describe the roller coaster ride. So we're looking at this graph over here. This is the height in feet. This is the time in seconds. So as you can kind of imagine, this is when you're getting on the ride at this point, right? And this is kind of what the roller coaster is doing. So during this part, you can see, okay, getting on the ride, the roller coaster left the gate. And was just basically going flat. Going flat. Until, dun 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 dun, it started up a large hill. So this is a little bit like the Titan at Six Flags, right? You're going up the hill, then it at the top, a sharp decline, right? This is the fun part where you're going down. We're decreasing at this point right here. Super fun. Then it goes up for a while. Actually, it goes until it's even with this. Then up again. Up another hill. Down again. Right here is down. That's pretty steep right there. Quite steep. And then it's flat for a little bit. Flat for a small amount of time. Then up again. Up and down. Until into the gate. Well, the end. And then they go in. Alright? So that's what this describes. So what we're going to be doing is we're going to be taking these explanations and drawing similar ideas. So in a single day, it snowed lightly during the morning, then heavily for the rest of the day. Graph the time on the x-axis, so it's telling me my x-axis is time, and total snowfall amount on the y-axis. So this is snow amount. All right, so we're supposed to graph it. It says it snowed lightly during the morning. So it's going to be snowing, and we're saying that the amount of snow is light over time. Okay, it actually probably started right here because it maybe started with 0. At 0, it started very light over time. This amount of snow increased, but not at a very rapid rate. Then heavily for the rest of the day. So as the day went on, the snow amount went up until the end of the day. All right? So at some point, it started snowing heavier. So that's what a graph like that would look like. What about this? Mia bought a painting. The value of the painting dropped by 25% after 1 year. The increase in value over the next 5 years, reaching a value that was twice what she had paid for it. If your x-axis is time and dollars or value is on your y-axis, what does that look like? Well, let's say Mia bought the painting at this amount, but they said after 1 year it went down. But then over the next 5 years, so this would be year 1, year 2, year 3, year 4, year 5, year 6, because over the next 5 years, 1, 2, 3, 4, 5 years, it doubled. So it went from this value to double that, which say is about up here. So it increased like that. All right. This is hopefully about double that amount. All right. So after 1 year, but then over the next 5 years. So do you see what's happening? You kind of have to be able to visualize and think about these. Moving on. So we've got a basketball is dropped out of a window on the 2nd floor at a school into the concrete below. Each time the ball hit the ground, it bounced and reached the height that was half the previous balance. It continued doing this until it settled on the ground. If your x-axis is time and this is height, so you've got a ball being dropped from here. Boom, and then it goes up half, right, half the height, and then goes down again, and then half the height, and then goes down again, and then half the height, and then down again, and then half the height, until eventually it settles. All right, that's what that would look like. Moving to the next page. Why don't you guys see if you can read 5, 6, and we'll check answers. So pause the video, see if you can do 5 and 6. Jace is speeding on the highway, gets stopped by a police officer. The officer gives him a ticket, and then he continues on the highway. I'm imagining at a reasonable amount of speed. Graph the time on the x-axis and his speed on the y-axis. So go ahead, pause the video, and try and figure it out. So here's what I would have gotten for this. He's way up here, speeding super fast. Boom, 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 boom. The policeman says, stop. He has to come to a complete stop, talk to the policeman for a while, get the ticket, and then leaves and goes up to a better speed for the area. All right, and then go ahead and try and do number 6. Keep in mind that your x-axis is the number of games and the y-axis is the total yards. So if this is total yards, then the number of, for the first 6 games, that would continue to increase. So at this point, this is after game 6. Then he doesn't get any more yards. So his total yards is increasing for the first 6 games. Then after that, he just has the same number of yards for the rest of the season because he can't play. All right. So when Alice drives a school bus on her morning route, she stops at every block to let students on. If time is on the x-axis and total distance, you have to be careful as to what they're asking. Total distance is here. Let's see what that would look like. Well, you'd start out here and you'd kind of go and then you'd stop. You're not increasing your distance, but you're increasing your time. Then you'd drive a little bit further, and then you'd stop, and you're not increasing your distance, but and then to get to the next bus stop, then you're gonna have to let those sweet little kids on, and then you go further, and then let the kids on, and then eventually you get to school. All right, so that's kind of what that would look like. Ray started his workout by running on the treadmill. His heart rate rapidly increased and the remaining height during his run. After the treadmill, he lifted weights. His heart rate increased and decreased during this time. So if this is the amount of time and this is his heart rate, he's saying that he started running and it went boom, his heart rate went super high. Then, after the treadmill, he started lifting weights and it kind of fluctuated, probably on a downward trend. All right? Last one. Carrie and Luke and Mason received the same allowance each month from their parents. Katie spent a small amount of her money in the first half of the month. Then she spent the rest of the second half of the month. Luke steadily spent his money throughout the entire month. Mason rapidly spent all of his money, in the first half of the month. Match each child's spending with the correct graph below. See if you can do that. So we've got Carrie, Luke, and Mason. What do these actually say to that? Pause the video. Figure it out. Which one is going to be Carrie, where you spend a small amount of money in the first half and then the rest in the second half? Luke steadily spent his money throughout the entire month. And Mason, who spends a lot of his money at the beginning and then kind of slows it down. Which one is which? So hopefully you got these answers. If you didn't, please go back. Don't cheat yourself of the learning. All right, so here's your homework. You're going to do this Unit 3, Homework 2, and there you go.